When we look at pumps, the parts of the pump that fail most readily are in fact not parts that the pump manufacturer actually makes themselves. We make the casings, we make the impellers, we make the bearing housings and so on. But the two most common areas of pump failure are in fact in bit seals and bearings. So we've got to look at what causes those failures and how we might fix them. So, in particular, vulnerable parts are seals and bearings. These components are not our manufacturer. They are made by a supplier as a bought-in item. So the quality of those things is within our control, but we're not actually manufacturing them. Most pump parts are covered by the manufacturer's warranty, but in fact, the bearings and the seals, that's a commercial decision that you guys make, how much you warranty those items. The cause of failure needs to be determined, since merely replacing the bearing or the seal may not deal with the cause problem. So you've got to isolate what actually made that seal fail, what actually made that bearing fail, before you can have an ultimate fix on the product. What we're looking for is an even contact pattern between the faces. So if we don't get that, we know that there's probably something wrong with the seal. And these are various seal problems that you can come across, and you can see that there's a much wider track on the stationary than is on the rotating face of the seal, which means that it's going in an eccentric motion. So there's misalignment between the stationary and rotating face of the seal. If you've got a situation where it's touching at one part and not another, that means that there's a tilt in the faces. And that means that maybe there's misalignment again. Behind the stationary, maybe there's a bit of swarf or a bit of dirt or something like that, and the stationary face is not flat in the same plane as the rotating face. You can have off-centre. Again, you can have a difference between the back cover, which has got the stationary face and the rotating element, that when you put the two halves together, they're not concentric. And then you can get chipping. That can be caused basically by mechanical problems. If you think of your little garden pick, when you chip away at your soil to break it up, that's what causes chipping on seal faces. But it's caused from some internal problem with the pump, possibly cavitation, that can damage seal faces, or it can be some other phenomenon that's occurring in the pump that is concentrated in that seal area. And then finally, you've got scoring and erosion. Dirt has got between the faces and it's damaging them. And that's the thing that we talked about earlier when we were talking about commissioning pumps. You want to make sure that no debris goes from that new pipework into the seal area inside the pump, because that will destroy a seal very, very quickly. And if you get a seal failure in a pump installation in the early stages, then it's almost certainly that some rubbish has got into the seal area. And then coking and crystallization, sometimes we pump fluids that are hot. And then when they cool down, crystals come out of the fluid and they embed themselves particularly around areas where there's close contact. So small gaps, you get crystallization and coking, and that means you have to reheat the pump casing before you start it again to bring those crystals back into solution. And if you don't, then there's a very high torque on the mechanical seal at startup. So you can't start it cold, otherwise you'll wreck the seal. Do I consider the mechanical seal as a wearing part? Ideally, no. But in reality, yes. So mechanical seals will wear if they're not adequately lubricated and if they are subjected to an environment that's aggressive. So a mechanical seal, for my money, is a wearing part and it will have a finite life. fitting of a mechanical seal needs to be done by a skilled tradesman. It's not something that can be done by just a fitter. He has to have done it before. He has to know where the seals are in the mechanical seal, because in a mechanical seal, you've not just got the seal faces to consider, you've got two other paths through which leakage can occur. One is along the shaft and the other is behind the stationary face. But yes, if it's badly fitted, it will leak. I can't really give you an accurate engineering description between balanced and unbalanced. But if we come to when you use them, basically an unbalanced seal will handle pressures up, let's say, to 16 bar. That's what they're designed for. They're designed for standard pumps. If you start to go to high pressure pumps, you need a balanced seal so that the pressure gap between the faces is brought down. Now, that's a design feature that the mechanical seal specialists can tell you about better. If you've got a seal problem, though, my advice to you is, if you're not sure what's caused it, it's not obvious from the evidence that you see, just talk to your seal supplier and say, look, we've had this problem. Can you give us some advice on what might have caused it? We're quite happy to send you the seal and you can have a look at it, and they'll send you a seal report. They might charge you some dollars for it. It depends how friendly they are towards you. But at the end of the day, seal problems are best dealt with by seal manufacturers.